Hello and welcome. Picture this. 50% of global population is considered now internet users, and 46% of global population is considered now mobile internet users. This is from Digital in 2017 report prepared by We Are Social, UK-based media company. This same report shows us another interesting data. Last year, for the first time in history, we have generated more mobile web traffic than desktop web traffic. I think that for the first time in the history. It is 50% of mobile web traffic globally to 45% of desktop web traffic, with great immaculate growth of mobile web traffic year by year, equaling 30%, as you can see. By the way, this is the data from, the report is from January 2017, so the data is from year 2016, obviously. We are in the middle of 2017 almost. How do you think this trend looks now? Oh, I think that we can look at this data from two perspectives. One perspective is global, and when you look at this from global perspective, you will see something that Google calls next billion internet users. They claim that there is literally billion people coming up online as we speak in developing countries such as China, India, or certain African countries, and that those people are most likely to come up online on mobile devices first, because this is the cheapest and the most accessible mean of internet connection for them in those areas. When you look at this data locally, though, you will see something in your own life, I believe. You will see that you switched vast part of your web traffic from your desktop machine to your mobile machine, maybe even major part of your traffic. So apparently there is a lot of people around the world doing the same thing, browsing internet on mobile, even more than you actually thought, I believe. What are our common problems? Obviously we have plenty of them, but bad internet connection, bad quality of internet connection can be one of them. This is true for those people in developing countries, obviously, but it's true also for us here, when we are commuting by subway or when we are going out of town for a weekend. We have the same problem with connectivity, with good, reliable internet connection. We have instead slow, flaky, or both internet connection, so-called Li-Fi. What is other problem? Mobile data and mobile data cost. It's true for people in developing countries, obviously, but it's true for us also. I find myself often not using certain application or website being on mobile data because it's just too expensive for me, or it loads for too much time. How much loading time is an issue for us? Well, actually, apparently quite an issue. 53% of mobile page views are abandoned, according to Google report from the end of last year, if the page takes at least 3 seconds to load. So if there is nothing you ship to your user for first seconds of his visit on the website, he's very likely to quit the website or application. While at the same time, 70% of mobile sites take longer than 10 seconds to load on 3G networks, on mobile connections. So there is apparently a big gap here. There is great need for performance, especially on mobile, and this performance is not delivered. We are living in a world where more and more parts of your application are becoming JavaScript. Maybe even major part of your application is JavaScript now, or it's whole written in some JavaScript framework based on JavaScript. So we are shipping daily to our users megabytes of JavaScript, while at the same time they have great need for good performance, especially on mobile, for quickly loading sites, for responsivity of your website, etc. So my name is Jakub Sowiński, as you saw previously. I am working in Stepstone Services as software engineer with 4 years of JavaScript development experience. And I came here today to give you a few practical tips for optimizing JavaScript so that you can satisfy this need for great performance of JavaScript applications in your own life. Let's start, or maybe I should say, let's continue, because we have just started with explanation. Why is it important to optimize your JavaScript application? Now let's move on to how to measure your JavaScript performance. When you want to optimize something, you need to measure it first and after probably as well. When you want to measure something, you would like to set some goals for you. You would like to know what is the purpose of your measurement. And in this case, obviously, the purpose of our JavaScript measurements would be to satisfy our users, to ship our products better, faster, more smoothly, more conveniently for your user. And This user satisfaction is directly related to basically what he sees on the screen. So what we do is we represent the loading time of your website on this kind of a film strip with particular events selected, highlighted, so that you can see actual experience of your user, especially on some flaky networks such as 3G, while this loading time is actually observable and meaningful for the user, and it can take up to 20 seconds, let's say. We will not discuss all of those events in details, but one of them is especially important. It's time to interactive. This is the event that you should put as much emphasis and focus as you can on this part of your loading time. It doesn't necessarily have to be at the very end of your loading page cycle. Actually, you should push it as fast as possible so that you deliver your application interactive as soon as possible, and then load everything what's not that meaningful later. There is also important distinction here on the picture between useful application and usable application. Your application or website is useful when it displays some content, displays some meaningful information to your user. That is not necessarily the same moment when he can already interact with your application. Sometimes it's later. But you want to ship your application useful as soon as possible and usable as soon as possible, obviously. Here is the example of something called progressive rendering. This is method focused on optimizing critical rendering paths, so delivering meaningful content to the user as soon as possible. On the bottom, you see the film strip of loading application that is not progressively rendering, so basically nothing happens, and then whole content is put on the screen at once. With progressive rendering, user sees meaningful content. This is the moment where application is useful for him after 0.3 seconds, and then everything else is loading, and after 1.5 seconds, the application is usable, fully usable. So this is something that you would like to have. How are we going to achieve it? Let's start with some measurements. Tools that we can use for measurements, there are plenty of them. My favorite one lately is Lighthouse. Lighthouse itself is not a tool, it's rather a set of rules and guidelines and checkpoints for your application. It was developed as a part of Progressive Web Application, this big initiative of Google. And itself is just a set of rules, but it has its implementation. You can use it as CLI application, but you can use it as well as Google Chrome extension. As you can see, the Google Chrome extension is quite simple. You have basically two buttons, from which one, the big one generates you the report and examines the whole website that you are currently on. It takes around 1 minute, maybe a little bit more. But the other one lets you select a few options that you would like to have benchmarked on your website. For our purpose, only performance tab is important, but the other ones are also useful for you, and you can see how your application performs or website performs in those metrics as well. This is the exemplary report from Lighthouse. As you can see, there is a point value at the top that basically describes how good is this website or application in Lighthouse's opinion. There is also a film strip with elements that were appearing on the screen and when were they appearing, and also measurements of first meaningful paint and time to interactive, the metric that we would like to focus on as much as possible. And also what you have with this report is optimization tips you could use to optimize your application. They are personalized per your application. You will see only those things that are actual problems in your application with wages, how important they are for your loading time. And also some diagnostics that might be useful. Lighthouse is very simple, but it's very useful. You just press one button and then you have everything you want to know about your performance. Yes, this is the example of report on full report of all 4 categories. And as you can see, you have the same point value, benchmark, and other metrics for each one of those 4 categories. This is another thing that is very useful for measuring the performance of your application or website. We all know this. This is Google Chrome DevTools. But especially performance tab is very interesting for this purpose. As you can see, you have their network activity, JavaScript main thread activity, etc. Also film strip. But my favorite thing here is this part. It allows you to select some network capping for given performance test. As you can see, there are a few presets already predefined by authors. You can also define your own preset. and then test the website simulating this kind of performance, this kind of network that you are using, so that you can not only test your website on your own development environment and supercomputer in office, but also assuming that you're browsing the website using mobile phone with 3G network. Other tools, well, apparently there are plenty of them, but all of them are made by Google. Google is pushing really hard this performance metrics and challenge for us web developers. There was some W3C tool, but it was abandoned 2 years ago already. So now it's only Google. You can measure your website in many ways using Google tools in terms of performance. This is result from Google Test My Site, for example. But you can also do this. This is very simple, and this is also convenient. You will know that your JavaScript code is performing better, is easier to download, at least for your user, when the size is slower, obviously. So also keep that in mind. Okay, this is it when it comes to simple tools that we can use to measure our performance of a JavaScript application or a website that uses JavaScript as well. Now let's move on to actual techniques that you can implement in your code in order to make it smaller or more performant. How to improve JavaScript performance? Well, basically there are two ways. You can either make it lesser or you can cache it better, simply. We'll start with code manipulations, which are focused on making your code lesser, smaller in size. Obviously, the most well-known and I hope used by everyone technique is minification and uglification of your JavaScript code. This is the result of Webpack Visualizer plugin that allows you to display distribution of code in your final package, in your final application. And this is application I have written lately. This is my blog application, simple React-based one-page application. And without minification, it has almost 1 megabyte of code. After minification, 3/4 of the code are cut. So I know that minification is really basic, but it's really fundamental. This is the most gain you can get in terms of performance. If you are not minifying your scripts, do it. Also, you can see that it differs depending on your project. This is different project. This is profile editor that we have implemented on our live environment. This is product, also written in React application, also one-page application. But it's much more sophisticated, much more detailed, has much more business logic inside. That's why 20% of it is our own code and only 80% are Node modules. And as you can see, this kind of application without minification takes 2.5 megabytes, more or less, and less than megabyte after minification. So this is not as successful method for this kind of application, but you will see later that those methods, they differ, their effectiveness differ depending on the type of application that you have currently. Precompression. Another simple thing you can do to your code in order to make it smaller and faster. Precompression is something that is done basically by your browser and server all the times. Whenever someone requests a resource, static resource from your server, usually if it's configured this way, but I suppose it is, your server compresses it probably to gzip format and then sends the package compressed, and the browser decompresses it, etc. What you can do, you can gain on compressing, it's because server compresses the package itself, right? But what you can do is to pre-compress it for the server so that you will avoid this additional small amount of time that it takes for server to compress those files on the fly. It's very simply achievable both in Webpack and in Rollup using simple plugins that are available online. And how much does it give us? Well, I did it for both applications. As you can see, size is significantly lesser, but this is not my gain. This is something that was already there because the server compressed those files for me. But what I gained are additional 200 milliseconds on first meaningful paint, just because the server didn't have to compress all files on its own. I delivered him compressed files already. The same gains you can see for profile editor, although slightly different, but the regula is similar for both of them. So I guess precompression is actually quite useful. It's a small thing, but there are many small things that you can combine, and then your application will be actually better performing, much better performing. Another small thing that you can implement is prepack. Prepacking is something that Prepack is a library introduced by Facebook lately, really lately, like beginning of May this year. And this library is focused on manipulating your code in a way that it's smaller, basically. This is the simple example. What does Prepack do is two main things. it eliminates abstraction tags, and it does computations during compilation time instead of during runtime. So that, for example, you have this kind of function in your code, and during compilation time, Precompression will make this kind of function just so that it takes less place, doesn't require this computation on runtime, etc. So the idea is, I think, phenomenal. Here you have other examples of what Precompression can do theoretically. But the problem with Precompression is that it's just the development version still. The version currently available is 0.2.2, which is not even a major release yet. And this is why it's not really working yet. I tested it on plain functions and on some vanilla JS applications, very simple ones, and it works perfectly there. But when I tested it on both applications that I had presented you here, the ones that have many dependencies, many common JS dependencies, etc., it doesn't work too good on those applications. Usually it just crashes. I mean, it returns some error that it couldn't prepack your code because of some dependency or some other thing. But this is something you might try. You might want to try on your own application. Maybe it will work for you, and for sure it will work in future for all of us. I think that this will be major point of our minification and optimization process during build process probably in future. So keep that in mind. Keep your eye on Precompression. Maybe test it already, but don't expect too much yet. And of course, if you have any issues with it, please create them in their GitHub. They are fixing them. They are basically getting feedback all the time, so it will be very helpful. Tree shaking. Tree shaking is very simple process in basically all modern languages that rely on dependencies or modularity, or however you can call it. And the process is about removing dead code from your application, basically. So removing all unused dependencies or unused functions, etc. Tree shaking in JavaScript wasn't fully introduced. I mean, it depends on module definition that you are using and bundling mechanisms that you are using. But let's focus on Webpack, as it's the most popular one lately. In Webpack, tree shaking wasn't available until version 2, which was released lately. In version 1, you didn't have this feature, but in version 2, it's very simple to implement it. You just need to tell Webpack not to transpile all, no, you just need to tell Bubble not to transpile all all new ECMAScript 6 dependencies modules to common.js and then back to ECMAScript 6. This is what Webpack 1 was doing. Webpack 2 doesn't have to do this. And using this technique, very simple, one line of code in your Bubble RC configuration, theoretically you can gain a lot. In Precompression, by the way, you have this out of the box, so you don't have to have any other configurations. Tree shaking is supported out of the box in Rollup. Some people claim that tree shaking gave them up to 30% of less size in final package, production package. In my case, it was 7 kilobytes at max I gained from that technique. So I can't confirm that it's working really well, but I suppose it depends on the type of application that you have. And for example, with a lot of legacy code or a lot of legacy dependencies, you will have bigger gain using tree shaking technique. So if you're using Webpack, move to Webpack 2 and start using tree shaking simply. Okay, this is it about code manipulations. Those were a few quite simple and maybe more advanced techniques. Let's see the measurements. My blog package, simple React application, is now almost 4 out of 5 lesser, 80%, almost 80% lesser, and almost 20% I gained on first meaningful paint. I think this is quite a lot. A little bit less on time to interactive, and my Lighthouse score has also risen, but it's not that meaningful. What is surprising for me is Profile Editor. Time to first meaningful paint and time to interactive have dropped immensely. I mean, of course, before testing those applications, I removed all minification processes that it had built already there and then reapplied them in order to see what is the gain. And the gain is great, especially for this kind of application. I gained almost half of my package size. I mean, almost half of time user was waiting for it to load on the screen or for first meaningful paint to happen. And also score is almost double, has almost double, but it was very poor at the beginning. So code manipulations, quite effective. You can gain a lot using it, but also quite simple. Let's move to code splitting, a little bit more advanced stuff. Why do we actually want to split our code is probably only for caching purpose, unless you are talking about HTTP2, where it plays a little bit more important role. But now this is the song for the future. For now, code splitting is used mainly for caching purpose. And this is the most basic and most fundamental technique of code splitting for JavaScript. What you do is you put all of your dependencies and code that is not yours basically to vendor package, so-called. And this package is, as you can see, consists almost entirely of Node modules. And this package is cached on user side, and it will probably never change or change very, very rarely, because this is not my code, those are my dependencies. I will maybe update them during development of my project a few times, but this is not something that will change daily, basically. On the other hand, we have app package or main package, or however you want to call it. As you can see, it's only 16 kilobytes, and only 10% of it are Node modules that I couldn't put in this package for some reasons. And it's much smaller. It's only 16 kilobytes from about 250 that we had for blog before. And this part will be often refreshed on client side, because this is actually the part when I'm putting my improvements, where I'm adding new features, etc. It all goes to this package. So it not will be cached for a long time. It will be often refreshed. But this is only 16 kilobytes I'm sending to the user. And all of this that is not changing stays on the user side forever, or maybe for a year, or it changes rarely, basically. Sorry. Another technique, slightly more advanced, is so-called route-based chunking. What you do is you split your code based on an entry point or on a route that user can take during his experience with your website or with your application. You split it by those entry points, and then user going through given entry point doesn't have to download full application and code related to all other pages that he's not seeing. He just downloads chunk related to the route he's taking. What does it give us is we are faster on the screen with first meaningful paint. We are faster interactive because other chunks are not even loaded at this moment. Maybe we will preload them later if we want. Basically, yes, you make your package that you deliver to the user in certain scenario as minimal as possible and as related to the certain scenario as possible. You can achieve this in Webpack, by the way. As far as I know, when I was last checking, Rollup didn't support code splitting because it's just based on entirely different idea of bundling the application. So this is not possible, at least it wasn't lately for Rollup. For Webpack, you can achieve it with 2 instructions depending on which Webpack distribution are you using. For Webpack 1, it was require ensure. For Webpack 2, it was system import. This is simple implementation of such a thing using React Router. How Webpack sees it is that whenever it sees this system import or require ensure instruction, it just from this point starts creating new chunk, new file. Everything that is after system import instruction will be put into separate chunk file. Very simple technique to implement, and in this way you can achieve those separate chunks based on routes. This is how it looks like after compilation. You have different JS files based on different routes, basically and simply. And as you can see, for example, given that user goes to the page which results in not found JS in your code, some page that you did not implement, he only downloads vendor, obviously, app.js and not found. All other things are left on the server side. And if you count it, it actually makes half of the size being downloaded by the user in that scenario. Very useful. Bonus points you can get for preloading additional stuff on the fly, basically. So when user enters given chunk, you can just place simple code in your head, and other chunks will be lazy loaded or preloaded when the main JavaScript thread will not be busy, basically. Code splitting, main and vendor, and route-based chunking, basically those 2 things. And lazy loading, that is actually quite simple to implement, but will be very meaningful when it comes to caching. Let's see the results of blog and profile editor applications. Blog application actually grew in size a little bit, 3%. This is because when we are splitting this code, it's not just splitted literally. It's wrapped by your module bundler in some maybe in some polyfills or in some functions, self-executing functions, depending on your module bundler, so that it is useful on its own itself as a JavaScript file is executable, so that the size grows a little bit, but it's not that I'm downloading this whole package now. I'm downloading only certain chunks. First, meaningful paint and time to interactive, better in both cases, slightly better, but still 400 milliseconds or half a second in that case, 10% is quite a lot actually. It's quite a lot, especially that Lighthouse, because those results are from Lighthouse. Lighthouse also tests your website on some capped network. I don't actually remember the specification itself, but you can even change this configuration in Lighthouse and test it under different capping. So 5 seconds, I believe, for 3G network, down to 4.5 seconds, quite a gain. Lighthouse score also grew up. I have no better Lighthouse score. That's actually my max for now, 79. Profile editor also grew in size, the same mechanism. First meaningful paint slightly dropped, but less than in case of block. And also time to interactive slightly dropped, but less than in case of block. I think that this is because of the specific architecture of this application. It doesn't actually have too much stuff to put into other chunks. It's single page application, like literally single page, there are no other pages. So maybe this is why those results are not that good. But as I said, you have many different techniques. You should apply them depending on your project, and depending on your need. Caching, simply. I believe we all know what is called caching, and we'll not discuss this in details. I would like to move on to something more sophisticated for JavaScript developers, which is service workers. I don't know if you are familiar with service workers. Those arrived made by Google and pushed by Google very hardly. I think 2015 was the first time they were available in browsers. The service worker is basically JavaScript background worker. It's a programmable proxy that allows you to intercept all requests that are sent to your website at their given scope and handle them manually, basically using programmable cache supported by service worker. What you can even achieve with service worker is to make your application work offline. If you have all the assets cached and all requests, all possible stuff that you would like to ship to your user cached, you can make it work offline as well. This is the example of the idea of service worker in practice. First time user visits a website, it loads normally. And after a certain amount of time, something is displayed on user's screen. With the second and the subsequent visit of the website, you will have your content served from cache first, and then it will be updated with something that was downloaded. So user experience is much better in this case. You see some content. Your application is useful for you immediately, almost, and it's usable after a certain amount of time. This is the technique that many modern mobile applications are using, and you can see them also on the websites that are behaving kind of like applications, maybe even progressive web applications. For example, Facebook. When you run Facebook application, you always see those old stories first, and then something is loading, you see the new stories. Exactly the same idea behind. But service worker is something you can implement in your browser, actually very easily. I will show you in a second, and utilize this idea. But first, is service worker ready? This is a website by Archibald from Google. He's very, very big supporter of those service workers, basically pushing them, being this first frontier of service workers initiative. So he created this website where he describes different aspects of service workers and checks if browsers are supporting them already or not. In case of service worker enthusiasm, all major manufacturers express this kind of enthusiasm, besides Apple, of course, because this is Google's idea, so Apple can't express enthusiasm. Sorry. But when it comes to actual implementation, if basic functionality of service worker is ready, it's ready in most of major browsers nowadays, besides Edge and besides Apple's Safari. By the way, this violet one is Samsung Internet. Interesting. Okay, so as you can see, service worker are usable, not really fully supported yet, but still very good step forward towards some progressive applications you can take implementing service worker for yourself. How to do this? Very simply. There are 4 events in the lifetime of service worker, and the first one of them is registration. You want to register your service worker when someone visits the website. So simple code in vanilla.js, you check if the service worker is available in navigator object. If it is, you pass a promise and registration is successful, otherwise you can log an error. By the way, what is important here is also scope. You register your service worker, which is actually a JavaScript file with all rules defined inside into the given scope, so that all requests sent to this scope of your application will be caught by service worker and then intercepted by service worker and handled manually as you program it. Next thing, installation or activation actually. When user visits the website for the first time, service worker is being installed. When it's a subsequent visit, service worker is being activated. How to install service worker? Very simple, using this code. As you can see, you specify name of your cache, and you specify, actually literally specify assets that you would like to be cached in your application. By the way, this name is quite useful for cache busting. If you want to bust your cache, for example, during development time, you can simply just change the name of the cache, and then you use entirely new cache simply, and the old one is busted. So, yep, installation event, and then caching events or intercepting events. This is basically the implementation of intercepting a request using service worker. When you see a request, you check if it matches to one of your caches or one of content of your caches, and then either return the response from cache or fetch it from online, simply. Okay, this is Archibald's cookbook, so-called. There is a very big article that he posted on his blog a few years ago, actually, already, where he described literally tens, or if not hundreds, of use cases for service workers with different architectures that you can use, because you can always, when you are programming it, you can always do it basically as you wish. You intercept the call, and then either you can call network, you can call cache, you can return some custom answer or some custom response. Depending on the use case, you might want to program your service worker in entirely different way, and it allows you to do this in very flexible way, a lot of very different use cases for that feature. We have actually did it ourselves in Stepstone. Last year we had something, actually we have this initiative each year. This is called Performance Days. This is this 1 week in a year when we can implement our own ideas based on performance gains that they can provide us. So we come up with our ideas, what is super gain for performance, and then have 1 week to implement it. So we spent last year's Performance Days implementing the service worker, and deployed it to production for like 1 week or 2 weeks, and the results that we measured on actual live production servers with actual users showed that subsequent visits of those users on our websites were up to 30% faster. Besides the fact that it was actually only proof of concept of the service worker, we only cached some basic, most common assets, didn't look too much into details, into different caching strategies or architectural design patterns that we could implement in this service worker. Service workers, by the way, have great support in terms of tools that you can use to work on your service worker. The simplest and most convenient one is Service Workers tab in your Google Chrome. Basically, each Google Chrome distribution have this tab, and you can check what active service workers are actually installed currently on your browser. This is interesting also from users' perspective. You can go to Google and go to Facebook and go to a few other sites and see how many service workers you will have installed by those websites, and check the content of the cache, see what is cached by those websites on your site. Very interesting experience, and this is also useful when you're developing your own service worker to keep checking if it's in proper status, if it's caching properly, etc. Also, Lighthouse offers a progressive web app category in its measurement, in its benchmarking, and progressive web applications part of progressive web applications are service workers, so it also can be used to check for your service worker health and implementation. What other features come with service workers? This is very crucial part of those progressive web applications. I will not go into details about those things today. I'm pretty sure that there is Thomas Steiner from Google presenting progressive web apps idea somewhere during the day. So I encourage you to visit his lecture about it, and you will for sure learn something about service workers. But implementing your service worker is basically one step, big step towards having this progressive web application, major step, the most fundamental one. Service workers come also with support for some great stuff not really supported by browsers yet, such as push API. You can see more and more often applications, websites are asking you for permission to push some notifications to your desktop. This is push API. This is what you can do using service worker as well. Background sync, so the idea of deferring some operations to the later time when user is back online. This is idea for those flaky networks that are sometimes online, sometimes offline. Having background sync, you can reliably just store all operations that user did and then send them to the server when it's available, when he's connected back. As you can see, Push API is supported by major browsers. Background sync is not yet supported. It is coming, but not yet there. So, but having the service worker, you are already prepared for those new features coming to browsers, and you are ready to handle them basically with your service worker. And combining all those things, by the way, service workers that we used and route-based chunking and lazy loading of stuff can make up so-called PRPL architecture. This is like creme de la creme or pinnacle of JavaScript performance optimization you can have currently. This is at least as supported as pushed by Google. What consists of PRPL architecture consists of 4 elements: pushing critical resources, rendering initial route, pre-caching remaining resources, typically using service worker, and lazy loading other stuff in the background using the technique related to route-based chunking I have just showed you. Combining all of these things, you can achieve this PRPL architecture, although it might require you to maybe make some other decisions on architecture level of your application in order, for example, to make it dividable into those chunks, route-based chunks. This is very interesting read. I encourage you to dig deeper on this topic. So caching, we learned about service workers, we learned about their lifetime, something about new features related to service workers, as well as PRPL architecture that you might be interested in. And this is it when it comes to caching, and this is also it when it comes to practical tips for JavaScript optimization that I have prepared for you today. I would love, and I would be very glad if you came out of this room today with a few of them, at least in your mind, that you would like to implement in your application and then maybe implement them, actually. But what I would love even more and would be even more glad if you came out of this room today with actual understanding, yes, of why is it important to optimize your JavaScript, understanding that in modern world, with those performance issues on mobile devices, and when we are writing more and more JavaScript code, it's only professional nowadays to put more emphasis on this part of your application and take care of it, basically. Thank you.